Hey everyone, welcome back to the workshop, and today we are taking a look at the XTool P3. This is their newest CO2 laser. It is 80 watts of power, it's bigger, and they have made it just about the easiest CO2 laser I have used to date. So I'm going to be giving you an overview of what it takes to get this set up. We're going to load up XTool Studio and look at the features between the software and the laser as to how it makes it very easy to get going. And we'll do a few projects as well to really kind of just dip our toe into checking this machine out and maybe give you an idea if it might be something that works into your workshop. So if you want to find out more, stay tuned. I'm going to jump right into it. So I've been using CO2 lasers for just a little over 10 years, and I'll tell you, they have come a long way. My first one I bought off of eBay, and I had to really figure a lot of things out myself. And through that struggle, I've gained a lot of knowledge, but there's been a lot of headache along the way. Well, the P3 definitely helps take a lot of that headache out of the equation. And so we're gonna take a look at that. But first, let's talk a little bit about how you are going to receive this laser. This laser is going to come via freight. It's going to be on a pallet. They are going to have a lift gate and a pallet jack. Depending on your dispatcher and the delivery, they may or may not wheel it into your shop, which you're going to have to just factor for that. It comes, depending on the accessories, it's going to be somewhere around 300 plus pounds. And so you may need some help getting it unloaded. So the truck driver was nice enough to drop it onto my trailer for me. I brought it around back here to the shop and was able to get it unloaded. I had to unpack part of the pallet because this did come with some extra accessories. Once you take delivery and get this into your shop or your workspace, you are going to need to unbox it. It is well packaged between some cardboard, some foam, and other packing materials. So just take care of getting into that and get some help moving it out of the box and onto where it's going to rest. Now, I highly recommend you pick up the mobile stand for this as well. It is built for this laser. It puts it at a nice height. I'm 6'5", and this is still a decent height for me as well. It assembles fairly easily. They've got some nice kind of interlocking, almost finger joints to get the posts and the frames in together. And then they do have the base material where the laser is going to sit on, and they give you some brackets to add 1 or 2 shelves. So I did go ahead and throw on the bottom shelf to give me some storage space. You're going to want to then make sure you have some help. Again, this thing weighs about 250 pounds. You want to enlist the help of 2 or 3 other people to safely lift it up onto your surface, whether it's something you built yourself or this portable base. From there, you're going to need to start unpacking everything. There are some screws that hold in the gantry. There's some screws that hold in the catch-all tray. And then we're going to need to start getting access to fill up the internal chiller with the antifreeze and the water. Now, the manual says to use purified water, but you want to use distilled water. The difference is purified water can still have minerals in it, and that can actually create conductivity, which is not good for your laser tube. As far as the antifreeze, if you're in an area where it could dip down below freezing, definitely going to want to use that. So they have a nice chart. You mix that up. So you're going to dump in the antifreeze first, then top it off with your distilled water. First time you go to turn on the laser, it will cycle that water through the tube. So double check the meter in the back. There's a nice little water level spot. You probably going to need to top off that water just a little bit more after it's fully circulated. It's good to let that run for a little bit, let it work out any air bubbles in the system, because those can have a detrimental impact on your laser. Outside of that, you do just want to make sure that any of the extra coverings and static cleans and whatnot are removed, as they will kind of get in the way. And then start hooking up things such as your power, your USB, and the laser does include the IF2 system. And so you see I've got it back here on mine. And that does Bluetooth link to the laser and automatically come on and off, and you can adjust the flow rate with that. So that works well if you're going to vent it out a window. In my case, I have it hooked up into my overall venting system, which also has an inline fan on there. This isn't 100% ideal. I'd rather it kind of just go direct out, but I'm not quite committed to where I'm going to put this laser yet. So I've just linked it into my setup, and I have extra hosing. When you're setting it up, Try to make sure that the hoses are as straight as possible and that they're as short as possible to your eventual outlet. You don't want any sharp bends. So on the back of mine, I do kind of have a sharp bend going into the fan. Once I really figure out where this is going to live, I'm going to try to make sure that that is as clean and as shallow of bends as possible. You just want to keep that air moving so that it has the best chance to extract that smoke as quickly as possible. Now, one thing to note is there is an e-stop button or emergency stop button. It's on the back right corner, and that is probably pushed in from the factory. So you'll need to twist that and that will pop out. If you don't do that, that will not allow the laser to turn on. That can be used if you have a really big issue and the laser's still running. You can hit that. That's going to kill power and stop movement within the laser, so you can take care of it. So one of the things that XTool has always kind of put it back out of the way. It's nice that you're not going to bump it, but that's the kind of thing you generally want up close and easy to get at. So keep that in mind wherever you're going to put your laser. You want to have access to that in case you ever need to use it. It's hopefully a rare occasion, but it is something to keep in mind. Also keep in mind that if that does get bumped and you go to turn on your laser and nothing happens, always check that switch as well. Another setup and safety feature is over on the left side. There are two ports here. One is a standard USB and this is a safety key. If this is not in the laser, it will not let you connect to it. You'll be able to turn it on, but you won't be able to connect or do anything with the laser. So in front of that key is a USB-C port, and that does connect with the included cable that goes back to your computer. You will need to do this at least once to get it connected. You can configure this on Wi-Fi, so you go into XTool Studio and go to connect, and once you get this on the USB, then you can actually set up the Wi-Fi password, and then your machine will automatically connect to your Wi-Fi every time. All right, so once you finally have everything hooked up, you can power it on, double check that water level, and get it connected into XTool Studio. You do need to use the latest version of their software. Once it does that, it will start going through a few steps of auto calibration. So it's going to want to sense that it is level, and it'll double check that, and then it will step you through the beam calibration, and that's to ensure that the path from the tube and back hits mirrors 1, 2, and 3 and goes down into your focus lens smoothly. They do include an integrated red dot beam at the source, which is nice. This is something I really wish I had had in my previous lasers. I wish I had it on my XTool P2. They did include it on the P2S, but it's also here in the P3, and that's one of the biggest things that causes people frustration when getting into CO2 lasers is the beam alignment. It's very frustrating to try to go through and hit the pulse and figure out which way the knobs are needing to be adjusted. The XTool Studio software will walk you right through that. It'll show you what adjustments to make, and it will walk you through the calibration. So do that. With the red beam on, you can kind of see which way the adjustments you're making are doing, and you want to get that lined up and in center as much as possible on mirrors 2 and 3. Now, as far as controls on the laser yourself, you might be used to some older lasers that had a whole panel and had some different weird menus that you had to navigate. They have a nice LCD backlit display here that also doubles as a knob, so you can twist it to go to the different functions, and then you can push down on it to double check things. But you can also put this into auto mode, which is their automatic creation system or automated creation system. And what that does is enable a lot of the cool, simple features for you. So the very first one is, as you open this up, the lights come on, but up top here, there's a little LED indicator. And so right now it's red, and what it is doing is trying to sense if you are placing material in here. So if we were to put some material in there, it will change from red to green and stating that it is ready to go. So we basically take a piece of material and drop it into the bed. We wait for that to turn green. Once it's green, we can close the lid. And now it is detecting the material. It's going to bring the laser head over to where it thought the material is. It's going to lift up the bed. It'll come back to its spot where it thought the material is, double check, minor adjustment, and then go park. Then back in the software, it will show you on the screen your material in the work area and ready to go. In addition to this, if you use material from XTool that has the little barcode and the QR codes on there, the camera will also read that and try to automatically set up the settings for you. Otherwise, you can jump in the software and specify the material that you're using. All right, we're here in XTool Studio. We are connected to our P3. You can also see that the IF2 is also connected. If you're wanting to double check the settings or add or remove things, you can come over to these three dots and check the device settings, and you can go to accessory information, and here is where you can double check that they are up to date, that they are connected. So we see here it also is looking for an RA3 that we'll be playing with that in a future video. But you can also change some of your settings here for the IF2 that is connected to it, and so we can adjust like the time it continues. You can put it in regular mode or quiet mode. You can have it in auto or manual, and so this will try to auto adjust based on the type of material and what happens. Manual, you basically just set a speed that it's going to run at. So if you have the AP2 Plus or Pro, that is their big enclosed air scrubber, air purifier. I've got their original AP2 hooked up to my S1. It works great. Love down the road, maybe get that one for this to not be venting out the air in the winter. You could also change and check like the filters there as well. So as you're getting your machine set up, the one thing that's going to be important is you're going to plug in your IF2. You're going to want to come up here and hit add and make sure that that IF2 is set into bind mode. Once the laser can link to it via Bluetooth, you'll be good to go here. So we started the automatic system, and here you see that it did drop in an image of our material. It has already lifted it up to its focus point. The next step that they make it a lot easier for you is they have a wide variety of materials. So if you come over to the right here under material, you can search for something similar. And so they have them by different types of materials. So we can go into here to wood, and we can look for something close. Now this is Baltic birch plywood and 3mm, so they do have one of those in here. So we can click on that, and then we would hit apply, and that's going to change our presets. Now it is going to warn us that this is a flammable material, and going too slow could cause a fire. So they are very, the first time you're running XTool Studio, they're going to have a lot of different pop-ups, kind of just helping you figure it out, and also kind of warnings about using it. All right, so we want to drop something in here, and so let's just go with a simple shape, and let's go with a, well, let's do the XTool logo. So we can drop this in here. I'm going to hold Control and scroll wheel to zoom in a little bit, get in closer. So we can drag this over here. And what you see over here is we've got some options for this compound vector. We have score, engrave, or cut. So if we wanted to engrave, it would engrave the parts in between the lines, and so it would leave that X open. Score would just draw a quick little line, but we're wanting to cut this out. So we're going to go to cut, and you see it's already dropped down some power options here. So it's recommending power 90, speed 30, and if you want to play around, they also include images of their test files. And so you can see here that they're actually a little conservative. You could probably go up even to, you know, the 45 and 90, 40, 35. All of these would be options, but they leave it conservative for a reason, in the fact that plywoods can have variations in them. They can have voids, they can have glue pockets, and those all impact the ability of it to cut through cleanly. So you would never want to come up here and say, okay, it just barely is going through at 55 and 100. You're going to want to back that off a little bit, but we'll just go with their recommendation right now of 30 and 90. And at this point, we can do a preview just to double check. So this brings up kind of a rendering. Now they're using a bigger object than ours. So this is if the whole bed was covered in material, but you see, we're going to have two cutouts. We're going to have that little X, and we're going to have the little shape of their logo. So that can be helpful when doing complex cuts. You can use this to double check what it's going to look like, double check that it's on a cut and versus a score, things like that. Once we are happy with this, we can go to our process, and it's going to, again, give us an estimated time, but also things that we may want to check. Now, they do have a fire suppression system on this. It requires a CO2 gas cylinder. I don't have that on mine, but it's just giving us a heads up that this is a flammable material and there is no fire suppression involved. And they want to make sure that the nozzle is installed. You can actually remove that nozzle. It's the air assist nozzle. It helps focus that air that's coming from the internal air pump. in onto your cut. And with cutting, you definitely want that to go. You can look at some of the tips to see what else might need to be there, and a safety reminder that, hey, this is a flammable material. So when we're all good with that, we can go ahead and hit start, and then we have to run back over to the laser, hit the button to have it go. All right, so you probably can hear the fan has already started, so that's warmed up. This is lit up blue. It says processing ready, so all we need to do is hit the button, and it will start the job. All right, the job has completed. We're gonna let the air run for 10 seconds to filter that out. The bed comes back up to kind of its preset location, and this turns green, says processing complete, and you can also hear that the fan turned off. So everything kind of automated for you. Now we can go ahead and open this up, and our material did cut out, but it fell through the slats. Just gonna reach under there, grab our bits, and here we are. We have our little cutout. It actually cut very well. The edges are not charred, they're just caramelized. That's one of the nice things about a CO2 laser, is that it's a much more efficient burn, so the cutting is much more efficient and cleaner. So now that I've shown you how easy this is, I want to work through a few projects to highlight some of the other features of this laser and why I'm excited to get it. And a lot of that is geared around why I originally got lasers, which was to work with model airplane parts. So this is a 36-inch wide bed. My past lasers have been under that. They've been anywhere from 20 to 27 inches. I've never been able to fit a full 36-inch wide sheet of balsa wood on here. So I'm going to get that ready. We're gonna cut out some model airplane parts, and I'll show you again how easy that is with XTool Studio and the P3. All right, so as nice it is that XTool has a lot of preset materials, balsa wood in different thicknesses is not necessarily one that's in there. And so we're gonna use another tool within XTool Studio to kind of figure out our settings for this. So this is a sheet of 3/32 inch balsa. It's about 4 inches wide and would have been about 24 inches long. I had already used this for another part, but we're gonna use the camera feature on here to place a test grid onto this remaining part of this wood. So we're not gonna be wasting a fresh clean sheet on just dialing in our settings. So again, we're gonna use the rest of this system. I'm gonna drop this down into here. We're gonna let this light go from red to green. Go ahead and shut the lid. And now it is gonna detect the material. The head's gonna move over. The laser is gonna lift up to set that focus using the LiDAR. And now we'll be able to jump back over to XTool Studio. All right, we are back here in XTool Studio, and we still have our little XTool logo cut out, so we're gonna go ahead and delete that. But you see the piece of material that we placed in there is in there in the software, ready for us to drop some items in. So to do the material test, what we wanna do is first start with a vector shape. And I like using this kind of raindrop one. If you do just squares or just circles, your results can be a little bit skewed. So using something that combines a right angle with some curves, so this would work, hearts would work as well, but I tend to opt for this one. So we are going to scale this down a bit. If you go too small, it's never gonna get up to the actual speed. So we're gonna do this first as kind of get in the ballpark, and then we will maybe dial it in there on some larger pieces. So just keep in mind when you run this test, too small parts may skew your results at the higher speeds. But we are gonna scale this down. We can actually come up here. Aspect ratio is locked, so I want these to be about 12 millimeter. And we can close this. We wanna move it over to the cut because we're gonna be cutting through the balsa. And then you may want to come over to this third from the bottom. This is your applications menu. Click on that, and then we want to go to material test array. And from here, we can start figuring out our speeds. Now, when I'm cutting, we're going to be in the upper power range, so we don't need to test cutting below, say, 50 or 60. So I'm going to limit this to 60 to 100% power. And our speeds, this is very, very lightweight wood. I'm anticipating we can get through this very quickly. So I am going to actually start our speeds around, let's say 80. And then let's go up to 140. And if we zoom in here, well, I guess we can't zoom in here, but you can see we also have our rows and our columns. So power wise, we have 60, 70, 80, 90, 100, which is great, but here it's jumping from 80, 95, 1, 110, 125, 140. And that's kind of a broad range. We can actually jump this up a few more rows to get a little more granularity. So here we can go 80, 90, 100, 110, 120. That is kind of what I'm looking at. And then it also has your 60 to 100. So when you're happy with that, we can hit done. That will automatically set your power scales for all these layers. And just to make this fit, since it's too tall that way, we're just going to rotate this 90 degrees and bring this right up over here, which is a nice thing about this. We'll be able to use this camera function to get this all lined in. And when we're happy with that, we can go ahead and send it off to the laser again. All right, so our test cut finished up, and I can already see as watching it, we were too slow because every single one of these blew through there. So we will go ahead and run this again. We're gonna jump that speed way up, see if we get it to the point where it can't cut through, so we can really dial in where we need to be. Now, one of the cool functions of XCS with the P3 is they do have 2 cameras that you can do real-time monitoring. So you can see we are seeing what the laser's doing. We are also seeing the time remaining and such. And we can even switch to a corner view. So if I go to the side view, they've got a camera in the corner of the laser, gives you kind of a little bit of wider view if you're not working exactly in the center. So just a nice extra feature, be able to use these cameras for monitoring the progress of the job you're working on. All right, so that second one finished. And kind of the same issue is that everything is getting blown out, no problems there on this one. So it could be that it's not getting up to full speed. We definitely could speed this up quite a bit. So I'm going to put a ridiculous speed on a small item here and just see if it reaches that speed and if it cuts out. All right, again, one of the nice features of this software with the positioning system, we can use this to drop something in. So we're gonna just let's grab this double arrow and get that out of the way. Rotate this and bring it over here. You're gonna get that just in there so it can maximize that out. All right, we're gonna go to cut, and here we're gonna stick at 90, but we're gonna crank the speed way up to, well, 300 is the fastest it will do. So we're gonna see if it cuts through here still. If it does, we're good to go. All right, that was super fast. And as you can see, it did cut that out. It hit that mark real well. So that kind of positioning with the camera works super great for using up material like this. And here is the part that was cut out. Our edges are nice and clean, just a little caramelization. So let's go ahead with that setting and we'll jump into using some of the actual parts I want to cut out on some real wood. All right, so I've grabbed a piece of the balsa wood. This is 6 inches by 36 inches. I've never been able to cut a full sheet like this. I've usually been limited to 24 or even less with my other lasers. So this is gonna be fun. This is some real flat, properly milled material, so it's very consistent, but you can have different grain variations and such in it. So now the laser has slat beds, much like the P2 had. It looks like there's maybe an area that a honeycomb could go, but for a laser like this and cutting, unless you're doing really intricate things, a slat bed's better because it doesn't have as many contact points where you can get that flashback. Now these slats do just slide out of their spots and we can add them closer together or spread them out. And they do have just kind of this V shape that minimizes that impact point. So the fact that these come out make them a lot easier to clean. You can just spray them down with some degreaser, wipe them down, and that will help clean them off, and which can help prevent, if you are getting extra kind of soot and flashback on them, that can be because these are starting to get dirty. Makes it really easy to clean these, but since these are 36 inch wide, I do need to put some over to the ends. So we're just gonna move a few of these out to support it. There we go, that should be good. And we will drop this in, plenty of room side to side. I'm gonna put that about in the middle. I'm gonna wait for that to turn green, and then we can close the lid. Here we go, 90 and 300. We do a single pass, and One thing they also include is this tab generation. So tab generation is putting in just little breakpoints in the lines. So that's useful, especially when using the conveyor, but I also want to use it here. We're cutting out these parts, and as the air moves over it, the air assist, it can blow them out of the way. I actually want these parts to stay in the sheet as if it was in a kit. So we can click on tab generation, and it will say number of tabs, tab cut power, tab size, and so we can do it generate by number or by spacing. So depending on the part, if you have bigger parts, you could do it by, say, every 3-4 inches. But in this one, since we have some smaller ones, I'm just gonna go by number. And we're gonna put, unfortunately, the smaller items don't need as many, but 3 tabs should hold all these parts in. So this will be a good test for that as well. So this is going to prevent any of that areas of dropping, and then you can just score them with an X-Acto blade. So with tab generation on, our cut and speed settings are ready. Let's go ahead and process this. Now with Balsa and these really thin tabs, we should just be able to kind of poke things loose and pop them out, break them free. Otherwise, you can use a hobby knife and just go along and score wherever there's a tab and pop the pieces out. And so this is really cool that I'll be able to cut wider parts on here, close to that 36-inch width, and be able to really maximize the use of the balsa wood and not have to cut it down. All right, before we move on to our next projects and tests, I do want to show you the cool feature of this having a nice big crumb tray. And so there are 2 screws that you need to remove to get this out the first time, but then after that, this whole bottom part will slide out. You can just kind of shake everything down into the corner, get it out of the way. Now there are these little white rubber silicone type tabs. You want to make sure that those slide in to kind of help lock it in place. And there are just some rails that this will slide into. Push these white tabs down, and you hear it beep that it's sensing that it's back in there. It doesn't want to run without that in place. So nice to have, lets you clean up that bottom area of anything that's dropped really quickly. You don't want to let that get too cluttered because the beam come through and some material could actually start a fire in there as well. So it's good to clean that out every so often. One of the nice things that the 80 watts of power on the P3 will provide is better cutting of some materials. Now it's always nice to be able to source materials locally, and here in the Midwest, we've got Menards and Home Depot, Lowe's, but I like shopping at Menards because it's one of the closest ones to me, and they have a little more variety of wood. Now, it's not always the best for laser cutting, and this is a type of material that I've gotten before. It's a little heavier. It is a natural maple veneer with it's like an MDF core to it. And some of my other lasers, including the P2, have struggled to cut through this pretty well. So we're gonna drop a material test on here, see what we can get for some speeds, and then hopefully we'll be able to cut and use a bigger piece in there to make a bigger project as well out of this material. All right, that's cut, finished. The rails were supporting some of it, and some of the others are hanging on there. So I'm just gonna tap this into the garbage, see which other ones want to fall out. So here we are, just the dropout ones. So we're getting up to even 21 millimeters a second, 100% power. But you see on the back, a lot of these are actually mostly cut out. So I like to just tap them and see if they'll just push out with just a light tap. I'm kind of okay with that. It's when if you have to push too hard, that's when it's probably not going to be a successful cut. And some of these too, it's just kind of like the start-stop point. But so there we go. We're getting through at, I would say 19 to 20 millimeters a second at 80 to 90% power on this material, which is great. That allows me to use this material I can pick up locally. So let's drop another design in, and I've got some bigger sheets of this. We'll try to see what we can do to maximize the working area of this one and make a nice piece of wall art. So I've made a few of these kind of wireframe profile views of aircraft before, and I'm just trying to stretch this out just to really maximize the width of this. And I'm going to drop in another one just to kind of fill out the board, and then we'll go to enter in those cut settings from the speed test we just completed. Oh, that's a good sign. The bottom piece of the wood came off. Top part came off. Looking good so far. All right, so here's the first one, was the Corsair. It's on top. So some parts hanging, but that is, you know, I haven't tested the kerf on here. The thicker material sometimes will hang up instead of dropping cleanly, especially if it has a tight, like a thin kerf that doesn't really move a lot of material out of the way. So I think most of this is going to come out. I'm just having to basically poke them through. I'm not ripping any fibers or anything, but we'll see. There might be a few spots. Actually, you can use a hobby knife just to be able to poke through some of these thinner ones. All right, so here's the first one, Corsair. Only a couple of things that I had, just little spots that I had to just like a real small fiber. So that looked good. I didn't have to ruin anything to get it out. I am going to sand this down real quick, but let's get the B17 out as well. All right, so here's the B17. Everything looked good other than right back here, there's actually a line that didn't complete, and that's just programming issue. I should have checked the file a little more closely, but this is just under 36 inches from nose to tail, and looks pretty cool. So I will probably sand this down. I might even paint it black. If it's on a white wall, it will stand out better that way. And yeah, that's pretty cool. All right, so I am going to try something. I've put that B17 back in there, and you can kind of see where the line was missed. And if I come over to here, you can see it's definitely not in the file. So I'm going to use the close-up shot. There is a camera on this. We're going to click that, and I'm going to come over here. What it's going to do is move the laser head over directly over top of that and take a high resolution straight down shot of that area. So there you can kind of see where it is nice and clean, and you see there's just that slight difference, but it's higher resolution and such. So, I mean, this piece is already cut, I already pulled it out, but let's just see if we can't add a line right here to finish this off and make that drop out. So I'm gonna come from there all the way over to here, and we're gonna make that a cut. And we wanted that, I think we did 19 and 90. So we're gonna go ahead and send that in just that tiny little cut and see if it works. All right, that did not take long at all. Let's see if it actually cut through it. So, does look like it finished it on that side. On this back side, I don't know if you can see that. There's just the finest little spot, but let me see. Yeah, I'm able to push this through. So with that close shot, the head moving directly over this gets a really precise alignment. I was able to fix the problem. This isn't a scrapped piece. So one of the nice features of this, the multiple cameras that definitely help you line it up, it makes it a lot easier to fix problems like this. Now that isn't always the case, and doesn't mean you couldn't do this with other lasers with, you know, absolute coordinates and careful measuring, but 30 seconds, I was able to fix this. It's really cool, something that makes this laser work a lot better for me. So we worked a larger project through the standard bed that is about 18 deep and 36 inches wide, but it does have another feature that we should be able to extend this even longer. So there is the conveyor feeder that we need to load into this. We're gonna wheel this out and set that up. This gives us a 24-inch wide working area by technically maybe infinite, but I've got an 8-foot piece of material. We'll scale it from there and see where it lands. But I'm gonna get this moved out. I'm gonna get the cartridges and everything loaded in for the conveyor. And then we'll see if we can get this loaded up and check that out. This is where the rolling base works really well. We can just slide this away from the wall and get it into a place where you have plenty of room in front and in back of the laser. Just make sure your exhaust is still in place. And they do have screws holding this back panel on. Those is magnetic. And there's one on the inside as well. You want to open those up and then take the screws off the front panel. Again, these are magnetic, so you don't necessarily need to replace those screws. Now the cartridge will slide in. You want to make sure that X is facing up, and then the cable will get plugged into the side. And then coming back around front, you can put 4 screws in. Now this rear cartridge can stay installed. You don't need to take this out each time. You just put those magnetic covers back in place. Then on the front side of the lifting platform, there is a bar that you need to install. They do recommend removing this when it's not in use, as it can get in the way of some material. And that there's a small sensor you need to open the cover for. Now we can slide on the brackets. There's a little slot on the right side on the back that you need to slide in, and then they lock in place the thumb screws. And then up on front, there's another slot on the left side. Just slide those in place and get them locked down. All right, so I have this almost 6-foot piece of plywood. It's about 24 inches wide, so that should fit into the conveyor. I'm gonna get it loaded into here. You do need to open up the little sensor on the front rail first, and then we're gonna line it on the back edge. And then the laser will be able to take kind of a stitched picture of this. You gotta leave the lid open. It'll take a series of pictures to get a good overview of this. So let's get it loaded in there, and then we'll jump over into the software. All right, on the back side here, I like to just get this lined up to this back edge and also squared up. So just try to get it to where both sides are flush on here, and that's assuming your panel's 90-degree cut. But that'll help making sure that this is straight all the way through. So once you're happy with that, we can go back into the software and tell it to grab the material. In XTool Studio, it detected the conveyor, so it switched over to that. So now we want to tell it to clamp down the material. It will do that, and then we need to tell it to take a preview, and it's going to go through and stitch these photos. So you do this here, it's reminding you to open up that sensor, and you'll see it just kind of moves forward a chunk at a time, taking a picture, moving forward, taking a picture, and when it's complete, we'll be back in the software with a full view. We're back in the software, and you can see now they have stitched together the material. Even if we zoom in here, you'll see you're kind of catching where some of the little imperfections in the wood, these little knots and whatnot are. So it's kind of nice that you can work around that, but now we can go ahead and drop our material on. So sticking with the aviation theme, I'm going to be doing this kind of old style wing rib. We're actually going to also cut out the gussets out of another material that's smaller, but for this one, I want to see how big we can get this. So I'm first going to rotate this, and we're going to size it up a bit, but not too much. Drag it over here. The nice thing is we'll be able to maybe use more of this down the road. I'll just be able to rip that down on my table saw, but we're going to try to maximize this. So bring that up about as high as we can. We'll stretch this out just a touch more as well. And yeah, I think it's probably about as close. Maybe we can squeak just a little bit more. There we go. Let's just really maximize this up. So we've got that ready to cut. Now, I did a cut test on this, and the thing to keep in mind is you can only do this once. You can't refeed it. I don't think it's going to keep its location the same. So you want to do it all in one go. So I ran a cut test on this plywood, and it was going through at 24, 25 millimeters a second, but I want to make sure we get through it all. So I'm going to have that down at 20 and 90. And the other thing that you want to keep in mind with the conveyor, if you're cutting, you want to add tabs. We are going to add tabs, and for this one, we'll just go by number, and I'm going to put in, honestly, I think 5 will be good. It'll probably be a bit much on the triangles, but 5 on the rib. Really, we just need like maybe 2 or 3 top and bottom. So we'll go with that. Hopefully that's not too bad for these other triangles as well. With that, we've got, you can also put the tab cut power to percentage. So if you wanted to try to cut partway through and just leave a little bit, but I'm just leaving a 0.5 millimeter all the way through. Other than that, we should be good to go. So we can hit process, and it's going to tell us this cut is going to take just under 8 minutes. So let's go ahead, get the laser closed up, send this off, and see how it comes out. All right, so the cut completed, and the tabs did hold it in, and we should just be able to kind of pop this out. You see some of them have come loose, so they should just kind of break free on this. There's the big one. And so just to kind of show that it is really actually cut through. So there's, you can see the cuts popping through, and so it really is just a matter of popping these parts loose. If you're a little stuck, you could also use a hobby knife. Now here's one spot, there's an imperfection in the plywood, so I'm gonna have to score that. That's not the fault of the laser, that's just this kind of not terribly expensive plywood that I bought for some of these tests. So obviously if you're doing this for, you know, like actual paying jobs, you wanna use some quality material so that as you run this through, you're a little more guaranteed that everything is going to cut and be clean. Otherwise, you're going to find yourself with a lot of extra work getting it popped out. So I'm going to go ahead and pop all these out, and then we'll take a look at this as it's done. All right, here we are. One 6-foot long wing rib. And then I went ahead and added those little gussets on there. Now the real ones back in the day, they were built up out of spruce, and these individual, you know, stringers and long rounds and such would have been glued in place, and then the gussets created extra strength. So that's why I put them in there, just for kind of artistic value. I'll probably go ahead and maybe hang this up in my office, or maybe even up on this wall here, but just a kind of a cool sample piece of testing out the conveyor. Definitely going to do more with that and really kind of push it, see what else we can create. But figured this would be a fun first test for using that conveyor, making something definitely a lot longer when it fits in the laser bed normally. At 80 watts of power, we should still have some decent cutting capacity. Now they do have separate lenses for this. The default one that comes in here is the M for medium. They also have an S for short and L for long. And those are kind of the focal distance of the beams, and they have a different effect. So the short one is going to have a narrower focus spot size. So laser beams kind of come in and then go back out of focus like an hourglass. And on a short focal length distance, that point where it comes to a focus is smaller, so you get a finer detail, but the distance that this inner part stays in focus is also shorter. So the trade-off to that is to go with the longer lens, and that way you get a longer focal distance, it stays in focus longer before coming out, and so you can get better cutting power, but the sacrifice is that focus spot isn't quite as tight. So you get a bigger, what's called a kerf cut, or removing material. So when cutting, and you can cut on the outside of the line, not a big deal. You want that more cutting power, you would go with the long lens. But if you're doing engraving and you want finer detail, you're gonna go with that shorter focal distance and that smaller spot size. So we only have the medium lens for this laser right now. I'm hoping to get the others later, but wanted to kind of explain why you would change those lenses. And so we're gonna be doing a cut test on this 3/4 inch poplar with just the medium lens. This is not going to show the true full capacity and cut power of this laser, because if we did have that longer lens, we would get probably a more efficient cut throughout the whole thickness of the material, and so we may get some higher speeds. But let's give this a test anyway. So the top two dropped out. 4 and 5. You see 6 and 7 here on the back side. Actually looks like, yeah, 6 slides out. 7 is just holding on. So you can just kind of see there's a little spot where it didn't break through. I'm probably, yeah, I can push that through. And there you see it's just kind of holding on. So 6 millimeters a second. Did make a clean cut. You guys see the start stop, but it's caramelized but not overly charred. So that's a good sign. Now, if you run into things like, you can see here, we've got this little knot on the wood. Those imperfections are gonna cause issues. So you may wanna run it just a little bit slower. It's always cleanest to run it in one pass. I don't know that I would go much slower than this. You do run the risk of fire, as the software mentioned, but there are, in the front and back, there are 4 sensors in front and 4 in back that they are looking for flame. And if it detects it, it's gonna stop the machine from moving. It should move the head out of the way, as well as there is an optional CO2 fire suppression system. It's built into the laser. You just have to get the cartridge, you screw that into the side. So if those flame sensors are triggered, it should dump CO2 in there, which is the safest way to put out the fire to do the least amount of damage to the electronics. It doesn't mean that it's not going to damage them, but it is going to be the most safe way to take care of that. So it's nice that it has an option, but never leave your laser alone when running an operation like this, really at all, but especially on materials like this that are going to be more flammable, have that risk of flaring up. But this is pretty good. Single pass, 6, maybe 7 millimeters a second, getting through 3/4 inch poplar wood. So we've just scratched the surface on what this machine could do. Did a lot of wood cutting tests and showing that automation of the machine with those materials. But if I kind of keep going down the path of testing everything this machine could do, it's going to be a long video. But I wanted to go more in depth and show you through the process, show you how really things react, and not just be a quick hype marketing type video. Want to give you a better view of how it actually works. And I am very happy with it. The automation tools seem to work very well. The material sensing, where it identifies that it is there, it uses LiDAR, gets that focus set, automatically brings that bed up, is great. The camera positioning is great. We were able to fix the B17 file using that camera and dropping an extra line in there on the part that was missing from the file. So the laser's tools work very well, and if you add in XTool materials and the barcodes, it's even going to sense what it is and pre-apply those material settings for you. All you got to do is drop your design in, tell it is an engrave or a cut. So it makes it easy for you. Love the features of the integrated IF2 fan that seems to be pulling the smoke out very well. Turns on before the job starts, runs about 10 seconds after. It's all automated. The red dot system in there for aligning the laser, that's one of the biggest problems people run into with CO2 lasers, is getting that beam aligned. That makes it simple, and it doubles as a framing dot laser as placing your material in there. So a lot of cool things about this laser that I like. I love the upgrade to 80 watts of power. That is going to allow me to work with more materials that I can source locally that might not be the most laser friendly, that maybe it'd make other lasers struggle. Really excited about that. Love the wide 36-inch working area, and the conveyor actually works pretty well. I've not been a huge fan of them in the past because of all the extra effort to set them up, all the extra space, but coupled with the rolling base and the fact that those brackets slide on and off, the cartridge can sit in there for the most part. I feel like swapping between just kind of the platform mode and the conveyor mode, you're talking maybe about 3-4 minutes, get things set up, moved around, and you're rolling. You're done with that project, take those brackets back off, another 3 to 5 minutes, park it back here, and it's out of the way. Some of the others, I felt like I had to set it up on a table and set brackets and make sure everything was locked in place, and it was an ordeal to get it set up. They've really made this easier to swap between the two, and I appreciate that because it means I'm more likely to use those features. So who do I think this laser is for? Well, if this is your first CO2 laser, this would definitely be an awesome one. It is a little bit higher priced than some of the other benchtop beginner lasers, but you're gonna get a wider working area. All the automation tools are gonna make it easier for you to have success right away. And that is a big thing. If you're gonna struggle trying to learn all of the tools and how to get things aligned, how to get things working, you're gonna get frustrated and you're likely to quit and give up. This does help out at that. It does come at a slight little bit of a premium price, but when you factor in, it has that red dot alignment beam, it has an integrated compressor-based chiller, has the integrated inline fan. A lot of these things are extras you would add to other CO2 lasers that are gonna increase that cost. So careful looking at the base price of one laser to this one, as you might not be factoring in those other tools. Maybe you don't need, but in my opinion, most of those I just named are ones that you're gonna want. Now, who might this laser not be for? Well, as I mentioned, there's a little bit higher price point, and so you may wanna scale back. The P2 and the P2S are still very viable CO2 lasers. They're nice benchtop models that get you started, and you'll still be able to work with those materials such as clear acrylics and engraving on glass without any binders, things like that you might want to step up into a CO2 laser for. The other people are gonna be the ones that really, really like to tinker. You wanna have your absolute coordinates and set up your fixtures and jigs. You can still do that with this one, but that automatic creation system, those automated tools, you may find might get into your way. And so similar to when I talk about 3D printers and Bamboo Labs are a wonderful 3D printer. They're great to get you started, but people who like to tinker get frustrated about how it is kind of locked down into their ecosystem. This does only work with XTool Studio. It is not Lightburn compatible. So again, if you are locked hard on Lightburn and have to use that, this is probably not going to be the laser for you. But they've spent a lot of time and effort building out XTool Studio over the years, and I've grown to appreciate it as a software, especially for people getting started in this hobby or as a business. It makes that jump into lasers just a little bit easier. If you are interested in the XTool P3, I will have a link down below where you can check out more about it. It will be an affiliate link, and I do get a small commission off you using that link at no extra cost to you. So if you are interested in buying this or any other XTool product, really appreciate you using that link, as it does tell XTool that you value my information and help support this channel with just that small commission as well. But most importantly, I hope I gave you some real honest information about this laser, how it works and what to expect about it, so you can make better decisions for you and your workshop. Thanks again for watching this. If you have any questions or comments, leave them down below. If you're new here, consider subscribing and hit that like button on the way out. I appreciate all of those interactions as it goes to help promote this channel to YouTube and tell it others should see it too. So thanks for watching. Hope to see you again in the future, but hope you get out in your workshop and make something too. We'll catch you next time.